Good morning, students. Welcome in your physics class. As we were continuing our chapter 2 in physics, units and measurement. And today our topic is propagation or combination of errors. Dear students, you are familiar with the errors occurring in measurement in physical experiments. Last day we have discussed different types of errors which occur during the measurements taking. Let us discuss the rules that are used to evaluate maximum permissible error in a measurement so that we can correct our errors to get the true value of the measurement. So today we will study about the propagation or combination of errors to determine the maximum permissible error. Let us first start with error in the sum of two quantities. We have to begin with error in the sum of two quantities. Suppose we are taking a physical quantity z, which is the sum of two another quantities a and b, given by z equals to a plus b. And you are measuring a and b, and after when you take the sum of a and b, some errors in measurement of a and b will occur, and henceforth the total value of z will possess an error. The physical quantity z is the sum of two quantities a and b. Let delta a and delta b are the absolute errors in the two quantities a and b respectively. Then the measured value of a will be a plus minus delta a. You have to write the errors with the average value with plus minus sign, such as the measured value of a is a plus minus delta a, and the measured value of b is b plus minus delta b. So if delta z be the error in physical quantity z, as you are measuring a and b and there will be some error in your measurement, that is delta a and delta b, your measured values are a plus minus delta a and b plus minus delta b, and if you take the sum to get the value z is equals to a plus b, z will also consist some error given by delta z. Hence z plus the measured value of z will be z plus minus delta z, which can be written as further. Now z plus minus delta z, as z is equals to a plus b, put the measured value here. Z plus minus delta z is equals to a plus minus delta a plus b plus minus delta b, and in this way, taking a and b together, a plus b plus minus taking common delta a plus delta b, this will, as we have z equals to a plus b, z equals to we have z is equals to a plus b. So here in place of a plus b you can put z. So our result becomes delta z is equals to, if you compare this z cancelled out, plus minus cancelled out, so delta z is equals to delta a plus delta b. So maximum permissible error in the sum of two quantities is given by the sum of their absolute values, absolute errors. So the rule is the maximum possible error in the sum of two quantities is equal to the sum of absolute errors of individual quantities. Individual quantities के जो errors हैं उसको सीधे तौर पर जोड़ दीजिए, their positive values to be summed up. Always remember. Now similarly in case of errors in the difference of two quantities, suppose z is equals to a minus b, that is difference of two quantities a and b. So if you put the values of measured quantities here and solve, you will get z plus minus delta a minus plus delta b after solving, and if you equate LHS and RHS, Z cancelled out, and delta Z, the value of delta Z comes out to be delta A minus plus delta B, and rearranging you can say that maximum error in Z, neglecting the minus sign, maximum error in Z will be delta A plus delta B. Hence, the rule for error in difference will be the maximum possible error in difference of two quantities is equal to the sum of absolute error in the physical quantities, dear students. For sum or difference of two quantities, we have seen that it will be the maximum error occurring in the measurement of z. In case of sum or difference, it will be the sum of the absolute errors in the individual quantities, say A and B. Number third is error in the product of two quantities. Suppose z equals to A into B, then z plus minus delta z can be written as A plus minus delta A into B plus minus delta B. After multiplication, you will get AB plus minus A delta B plus minus B delta A plus minus delta A into delta B. Since delta A and delta B are very small quantities, hence their product will be very small, negligibly small. How? Let's see. If delta A, suppose we are measuring some value of A and delta is 0.01, then and delta B is 0.03, then what will be the value of delta A into delta B? This will be more and more small, 0.0003. So it is negligibly small, so it can be neglected. The product of delta A and delta B can be neglected. Hence we may write z plus minus delta z is equals to, after neglecting this, AB plus minus A delta B plus minus B delta A, and thus we get delta z is equals to A plus A delta B plus B delta A. Hence dividing LHS and RHS by AB, we have delta z upon z is equals to A delta B divided by AB, B delta A divided by AB. Dear students, look in the LHS, the value of z is AB, so I have written here z in place of AB. You don't have to worry about that. Here AB and here also AB, and AB is replaced by z. So we get the value as follows: delta z by z is equals to delta B by B plus delta A by A. This is known as relative error. We have seen it. This is known as relative error or fractional error. So the rule becomes for product of two quantities that delta z upon z is equals to delta A upon A plus delta B upon B. That means the maximum fractional or relative error in the product of two quantities is equal to the sum of relative errors in the individual quantities. This is the sum of relative error. This is relative error plus relative error in B, relative error in A plus relative error in B, that will be equal to relative error in Z. So the product rule is like this. Now we will discuss about errors in the division or quotient. Let Z is equals to A divided by B. Some quantity Z is equals to A divided by B, where A and B are measured quantities whose measured values are A plus minus delta A and B plus minus delta B, and we have to find the quantity Z. We have to find the maximum error occurred in quantity Z. So we can write like this: Z plus minus delta Z is equals to Z plus minus delta Z is equals to A plus minus delta A plus minus delta A divided by B plus minus delta B. Taking A common from numerator and B common from denominator, you will get quantities like this taken in brackets, and then then we can write a by b under bracket plus minus 1 plus minus delta a upon a into 1 plus minus delta b upon b whole to the power minus 1. When we take this bracketed term in the numerator, the power will be minus 1. We have to take the reciprocal. So a by b under bracket 1 plus minus delta a upon a under bracket 1 plus minus minus 1 delta b by b. Dear students, this is in accordance with binomial theorem. We have seen it in the mathematical tools. 1 plus x to the power n is equals to 1 plus nx when x is very very small. Dear students, delta a is always very very small than the true value. Okay, suppose you are taking the acceleration due to gravity 9.8 and the error may be very small. Suppose this will be 9.82. So the measured value is 9.82. So error will be of 0.02. This is very very small. So delta a, that means 0.02 divided by 9.8 is a very small quantity. It may be neglected. That means condition is fulfilled here for binomial theorem, as delta a by a or delta b by b is very very small than 1. So considering it as x, you can apply the binomial theorem, and thus n, the power n comes before x and get multiplied. In this way, as a by b is z, z cancelled out and delta z becomes this, and the final, now we should not proceed this like sum or difference. We have to just divide both sides by z and we get the result like this: z upon z plus minus delta z upon z, z by and whole this quantity divided by z, z cancelled out, this will remain left. So we get 1 plus minus delta z by z is equals to 1 minus plus delta b by b. When we multiply this one to this whole term, and then delta a by a, 1 delta a by a plus minus delta a by a into delta b by b. Now since this quantity is very very small, negligibly small, as it is very small, 0.01 into 0.02 will be 0.00042. This will be very very small, dear student. So this quantity is very very small, negligibly small, and thus we get 1 plus minus delta z by z is equals to 1 plus minus delta a by a plus delta a b by b. 1 cancelled out from here, and you will just get maximum relative error in z equals to delta z by z equals to delta a by a plus delta b by b. Hence the rule for the quotient is the maximum fractional error in the quotient of two quantities is equal to the sum of their individual relative errors. Next we will see error in case of measured quantities raised to the power. Suppose z is equals to a square, where the measured value of a is a plus minus delta a. Then we can write z plus minus delta z equals to a plus minus delta a whole to the power whole square, and expanding the RHS we get a square plus delta a square plus 2a delta a using x plus y whole square. Now delta a is very very small, so delta a square will be negligibly small. Suppose delta a is 0.01, then delta a square becomes 0.0001, more and more small, negligibly small, dear students. So we can neglect it. The result will be z plus minus delta z is equals to a square plus 2a delta a, and thus since a square z is equals to a square, so substituting z in place of a square and cancelling z and z from LHS and RHS both, we get delta z is equals to 2a plus minus 2a. Delta z is equals to 2a plus 2a delta a, dear students. Now here plus minus is written in the RHS with respect to this sign, because this part will be equal to this part. In this way, delta z is equals to 2a delta a, and dividing both sides by z, delta z upon z will be equal to 2a delta a divided by z, and in this way delta z by z is equals to plus minus 2a delta a by a square. Since z is equals to a square, substituting a square in place of z, single a can be cancelled out, and in this way we get that relative error in z is equals to 2 times relative error in a. That means power comes to the comes before the relative error in a particular quantity. So the rule is like this. Hence the relative error in a square is 2 times the relative error in a. In general case, we can assume like this: if z is a physical quantity taken as a to the power b, b to the power q, whole divided by c to the power r, then the total relative maximum relative error in z is given by, you have to just bring the power before the relative error. So p, we have a to the power p here, so write p relative error in z plus q times relative error in b plus q times relative error in b plus r times relative error in c. Just you have to add by putting the power before the relative error to find the total relative error in z. So dear students, today's class is over, and you have to just note down all these topics in your physics main copy in your neat handwriting properly, and you have to practice it. You have to possess the better concepts on these combination of errors to find the maximum errors in your experiments and during the measurement of any physical quantity. So dear students, this was our topic, propagation of errors, through which we can evaluate the maximum errors in the measurement of some physical quantities. Next day we will do some numericals regarding propagation or combination of errors of a physical quantity. So dear students, okay, thank you.